In this video, let's work with for each loops and cool way we can use them to kind of randomize our geometry. So this necessity for me became when I worked on my pipe builder toolset set, pipe builder HDA, and I wanted to rotate the bolts around. But let's say I have this simple setup, just like in my pipe builder. You can see that, let's say I copied these bolts, but once I copy, you can see they're all in the same position. So for me, the necessity was I wanted to basically rotate in them individually. So, well, that would be pretty easy because I could put down a for each, and then I would for each that would be connected piece. So you see, it's gonna put down a connectivity node, but it's great for the bolts that are from one that consist of one primitive. But say I have these bolts and I have multiple of these. You can see they are not connected at all. So that would mean that however many pieces I have, it will basically multiply by 2. And if I would say, let's say I put down an edit node, and let's say for the group I'm gonna put down an asterisk. Let's say I want to, and then for the local frame, let's say I want to, you can see now we can rotate them, but of course every one of these, because it's by connectivity, since these are not connected together, it interprets each one of them as its own geometry, and it basically rotates around it individually. So this is not what you want. So we could just boolean out these two and create them as a one piece, but let's say we have something where we can't really do that, and we want them for each loop to interpret every one of these copies as its own unique piece that we can rotate. So how can we do that? Easiest way for us to do it is put down attribute create node before we copy to point these circle points. So in this, for me default is small parts. I'm gonna copy it, make sure it's integer, and its value is going to add ptnum. So actually it's not caps. Ptnum means basically it's just like a triangle. Once we put ptnum, this attribute is going to basically take the value whatever the point value it is that it runs over. So for us, if the point number is 0, it's going to put in attribute 0, 1, 2. So it's basically make sure that we have unique attribute values for each point that we're gonna copy to. And in copy to points, you can see already, once we copy it without doing anything by default, you can see we have all of these points. So let's select maybe, does it even show? Yes, so let's select one of these. You can see it basically selected all of the zeros with it. So this one can use in for each loop. And also it starts by copying the attributes. You can see it says copy everything except for these. So let's say we do not want to copy this attribute create. What we do is basically also write in this one, comma, caret, and small parts, like that. You see now it's deleted it. If you say basically copy every attribute except for these, and we also wrote in our attribute that we just created, but since you want it, let's delete this like that and leave it. Now that we have our attributes, all we have to do is put down a for each loop, for each name primitive. And one thing we have to change is in a for each, first of all, piece attribute is not going to be name, but our small parts attribute. And one thing also we have to, since we want to do it, piece attribute is primitives. We have to actually promote this since we have point. Let's put down attribute promote. And let's change from point. So we have our small parts is a point attribute, and let's change it to primitive, like that. So now we have made it a primitive attribute. Now we can easily connect it to for each. Now that we have our setup, what we can do is put down edit node. In a group, put down asterisk. Basically it says everything that inside here we want to move. So in transform space, put it to local frame, and in local frame, the way that we want to move it, it's normal plus vector. So if you take a look, if you start rotating, we can now rotate them. So we do this because in component, actually, you take a look at it, you can see it does not move by the axis. You see that let's move rotate it. You can see that it's all of three things rotates, and we can't really with randomization predict how it's gonna rotate with when all the three of them are moving. So just put it to normal plus vector or orient bounding box. You can see now it's moving in the one axis. Even in this tooltip it basically says that the method of determining local frame from collection of components. So all this, and now let's say I want to rotate in on the y-axis. And now all we have to do is create a meta import node. Go in for each begin, create meta import node. Let's call it randomizer like that. Let's copy it. And now all we have to do is reference this node inside our edit. So we want to rotate y. So now let's start writing detail. After that, let's reference our randomizer. After that, the attribute went to its iteration, and then 0 by the data type, like that. Basically, what we are saying, give me the detail attribute of this randomization node. You can see its detail, it's actually iteration 12. So basically, it's going by every loop, it's gonna get the number. That's where we get unique values for each one of the loops that it does. And you can see that at the end of it, you can see that our very last loop that we do, this one is slanted by, at the end of it, it means this one is slanted by 12 degrees, because we have 13 loops and the first one is 0. So basically the first one says, hey, don't move it at all. The next one is 1 degree, 2, 3, and so on. So by the last of it, we have 12 degrees rotation for each one of these. But since you want to randomize it, we have to wrap this around with rand function. So just rand like that. So at the end of it, you can see, now we can't really see because rand is a function that gives us random from 0 to 1, so we can't really see the 1 degree. But what we can do is actually, after the rand, you can basically just multiply it by 360, like that. Now we're getting randomization in 360 degrees. But let's say we do not like this position, what we can do is create a channel. So go back, edit parameter interface, go to integer, actually go to the float, drag it up here, call it rand. Let's copy, label it also rand, accept. All we have to do is incorporate our channel, and basically what we want to do is incorporate inside our rand function. So in rand, in all of these brackets, it's where it gets its value. So we're getting now randomized because every detail is randomized. But what we can do is, if we want to different variations, we can actually multiply it by this channel. So inside the brackets, after the first detail, which is first bracket, we can just multiply by ch, and for us it was rand, like that, and that's it. You can see the only thing is that our very first one is not rotating. That's because the randomization, the iteration amount is, although its number of iterations is 13, but iteration is 12, basically it starts with 0. So if you multiply 0 by any number, it's still going to be 0. So what we can do is actually edit this one rand. So in rand detail, basically what we do is wrap around this detail function, another bracket, and then just +1. So basically we're starting with 1, then we're multiplying by channel, and outside, once you get our randomization value from 0 to 1, we are multiplying by 360, and that's it. You see now we're now getting our randomization on all of the points. So this is how any sane person would do this. But if you want to do it completely unrationally, we can do is actually use a 2 loops system. So let's take a look. So basically the first setup is the same. We have circle, we copy the points, but this time we do not have any attributes. We do not copy any attributes, we do not have piece attribute or anything like that. So in the first loop, what we are doing, we are actually creating groups. And for our groups, we have a couple of important things. So first of all, we have our block begin, but for the for each end, you can see that we have iterations by count. And iteration is the amount of points that we have copied. So you see that this is basically getting the iteration amount is number of points that we copied to. You see it's referencing to the circle 1, and the circle 1 is basically the circle that we copied from the point. So this takes the iteration amount is how many copies we have. So we know that we copied to circle, we have 13 copies, so that's why this iteration is actually 13. So let's take a look back. This is we have 13 iteration of this loop. So in this loop we have our counter, which is also 13 times a loop. Now that we have matched our iterations with the amount of points that we copied to, let's take a look at actually how we create these groups. So first of all, when you create a group, and you have option to create manually, select the polygon. So let's select the first loop. You can see it's 0 to 11. Basically says from 0 to 11 polygon selection. So that's a 12 polygons for each one of the loops. So 12 by 13 should be 156. That's the amount of primitives we have. So let's delete this. And in our base group we have a couple of functions. First of all, you can see our hyphen, which is the same that has from 0 to 11, just with the functions, so that we can dynamically create these groups. So first of all, we get a detail attribute, which is, let's start with first loop, which is 0. So we want to 0 multiplied by the number of primitives in our first loop. So first of all, the number of primitives is basically referencing merge tree node. So number of primitives is basically the node that we are before we copy the points, how many primitives there are in every copy of this. So for us it's 12. So basically it's before we copy it. So now it's 0 multiplied by the number of primitives in this one. And that was 0 for us. So 0 multiplied by anything is going to be 0. So first of all, in first loop we have 0 hyphen 2. So detail, the same function, but we are adding 1 to it because we want actually the range. And if we are multiplying, since if it would be a 0, we would get a 0, but we want actually 11. So we are basically adding 1. So 1 multiplied by n primitives, that is 12. So 1 multiplied by 12 is going to be 12. But since we know it starts with 0, we actually want to subtract 1 from it. So in the very first loop we're getting 0 to 11. So that will be our loop with 0 in it. Now with 1 you can start to imagine. So 1 multiplied by n primitive is going to be 12, and then we get selection from 12 to detail plus 1, that would be 2, and 2 multiplied by n primitives minus 1, it would be, so 12, 23. So that's going to be from 12 to 23. And let's just for that, let's put on a group. Let's select our second copy. That would be this one. You see it's 12 to 33. And of course we also have to create our groups dynamically, because if we would leave it the group name with just a group 0 or what, it would actually override for each loop of it. So what I want to do is actually use the strcat function, which I have showed in previous videos. It basically combines the two concentration of two strings. And first string is basically just the name of it, so group, and then the detail of the loop that we run. So first loop is 0, group 1. Of course you could also change it to hello, and our group now would be hello 0, 1, 2, 3. Now that we have our groups, what we want to do is create an attribute from it. So what we can do is just copy paste this strcat, put down a name node, which is basically going to promote our groups to the attribute. So attribute is going to be name, it's going to be string attribute. We just copy paste in group and name it, and you can see under the name attribute you have our groups as a string attributes. So each one of these loops has its own, each one of these copies has its own unique name in our name attribute. So group 0, 1, 2, 3, 4, and 5, 6. Since it's all colored up, what you can do is actually, once you have created these, after the for each loop, what you can do is just group delete. And in group delete, just put down group and asterisk. So basically this is going to delete all the group that has group in it. You see it's now all cleaned up. We have just a name attribute with each one of these very nicely separated into each own group name. And now that we have cleaned it up, in the second for each loop, what we are doing, basically giving a piece attribute called name. This is our attribute name, and we can do basically the same thing as we did in the example before. Let's do it like that. Let's rotate. As you can see, each one of these are individually rotating. So these are two loops, which is basically the same thing, and of course, for much easier work, you should always use the first one. But why am I showing this? Well, first of all, I was working on this my pipe builder tool, HDA, and I upgraded it and created basically the pipe tiles are back. We can either this more organic or the classic ones. And in this video I won't go through it, but I wanted to go through the for each loop that I made for this to create this one. So first of all, we cut up all of this geometry, and for our cutting up this geometry I created this video on how to break up tileable texture redundancy, and I'm gonna link it below. You can watch that one for the loops that I created, but for the overview it's very simple. So first of all, let's go to the first one. It's in a video for me. So first of all, we bevel it. After that, we create our groups. You can see my group with this very simple function. We are basically saying from 0, which is always going to be, for the curl, is always going to be 0 point, and up to 10. So for me, it's actually up to 11. And for how do we get this 11? Basically just number of points of our curve before the beveling, and then we do a couple of math to subtract and add some of the points that will be once we bevel it. But you can see that it's possible because we are beveling it, and all of the first points are actually on the sides. So if our 5 would be like in the middle, it wouldn't really be possible because we would need the side points, and side points would be like 20 or something else. So that's good about bevel. So it puts our very first points right at the sides of it. So that's why it's even possible. So but then we polycut it. Basically we cut it in chunks of the points that we got this. So basically we cut our curve in these points with polycut. Then in connectivity we do it for each. In for each we sweep it, each one individually. You can see each one of these now are cut individually, and these holes are going to be hidden with the flanges. If you take a look at UVs, you can see we do not have anymore the very long UV one, but basically just stacked together on each other like that, and that's it. We're basically done with it. After that we add some color, merge it together like that, and that's it. So for the organic tube it's a little bit different. So I wanted to very fast go through it. So first of all we bevel it also, but now we are beveling to the maximum. So basically we have the same curve as with this first curve, but we are basically beveling to the events, the points intersect each other at the very ends of it. Then we fuse them together so that we do not have duplicating points. After that we put down a sort. Sort is very important because like that, let's put in points. You can see right now they are not sequentially, so we can 0, 12, 13 points. So after the sort node, we put it by vertex order. You can see 0, 1, 2, 3 now. Our points in a curve is in order. After that we put down a polyframe and we're gonna give it normal tangent. This is basically for us to make sure that our flanges are going to be copied by the actually that's going to follow the curve. So polyframe is also important. In our loops, first loop we're doing basically the same thing. We are creating groups with pretty much the same setup, only we are now selecting only 1 point for each group. So you see 0, 1, 2, 3 is basically where our flanges are going to be copied to. And we control it with, in feedback you can see for iteration amount, we are controlling by group create. So in group create we have a distance between the flanges, custom int value, and you can see if we change it to 0, you can see that we have more groups and distance is smaller. If we increase it, it's bigger, like that. This is where we control it. And once we have our groups, what we do is a couple things. First of all, we need to blast it to copy the flanges. Once we have Basically in this blast we are saying delete everything that has groups in it and then delete the non-selected. So only the places where one of the flanges are left, and then we just copy them on them like that. And for our second loop, for our tube is basically the same setup. We are basically sweeping it by each other, and also just like in that one, we are actually in a sweep, we are actually using the randomization role. So every one of these tube segments are actually randomly rotated on its own axis. So we get a little bit randomization once we put down our texture that is not so obvious that we're using the same texture. So then we normal color, basically the same setup as style 1. One last thing I wanted to add is about these gathering methods. You can see that in this loop we wanted to create our groups. What we have set up is gathering method is feedback each iteration. So basically after this loop we are feedbacking this result back on it. So you can see in the method we are basically fetching the feedback. So but if you, let's say, put it to merge each iteration, you would see that we are basically creating lots of copies of the same geometry. So basically the same geometry would be copied for each loop. You can see if I start selecting these and start push delete, you can see underneath there's lots of geometry. And remember we did use merge each iteration gathering methods in our multi-parameter blocks or HDAs, so there is a use for both of these gathering methods. It just you have to know when to use one or the other. So that's it for this tutorial. I hope you found it useful and see you next time.